Hey guys, we have a problem here that has a crowbar and it's being placed between two blocks of wood. What we want to do is we want to find the reactions at the three contact points. We've got a contact point here at A, B, and then C. Now the person using the crowbar is applying a force down here. Magnitude of that force is 10 pounds. It is at an angle of 30 degrees with the line that's perpendicular to the crowbar. Notice this says they are smooth points of contact, so you don't have to worry about friction or anything like that at the contact points. Okay, so let's go ahead and first thing we need to do is draw the free body diagram. That's always going to be your first step. Even if you don't want to do it, still got to do it. So let's draw the crowbar because that has all of the forces acting on it. Let's go ahead and start out with this 10-pound force. Right here, that's at an angle of 30 degrees. And now we need to look at the other forces. So if you think about the crowbar, it's making contact with A. Now if we're sitting here pushing this crowbar to the right with this force, this crowbar is trying to move this way, right, relative to this block of wood. Now the block of wood is not going to allow the crowbar to move up this way. It pushes it back. So there is going to be a normal force there. So we'll call it NA. It's going to be perpendicular to that crowbar and to the surface of the contact point. Now we've got the same thing at B. So it's pushing down here. That block of wood says no, 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 and it pushes it back up with a normal force. Let's call it NB. Finally, at C, we got the same situation. We're trying to push this down, block of wood works against that through the normal force in C. Okay, so these three forces here are preventing translation in the directions opposite to the force directions. Now what we want to do before we get started on the equations is let's look and see what coordinate system we want to use. Okay, so normally we use the standard just XY system like this. That's usually what we use. For this one, I'm going to switch it up a little bit just so you have an example of where we can switch up the coordinate system. I'm going to say this is X and now this is Y. Right, and if you notice, we've got two forces that are already in this X direction. Okay, so that's the system that we'll use. Now let's go ahead and let's look at the equilibrium equations. Let's start with the X components for the forces. Now remember, this is X, positive X. It's perpendicular to the handle of this crowbar. With that being said, we've got this 10-pound force down here. It's got an X component, and that is right here. Right, that's going to the right, so that's positive. And the force will be 10 cosine 30. Then we've got NA. Now NA, notice, is parallel with this x-axis. It's pointing to the left, so it's negative, but we just have to put minus NA. No need to worry about finding angles there. Then we have NB. NB is parallel to this new x-axis also. This one's going to the right though, so that's positive NB. And now we've got NC. So NC is in the regular old vertical direction, what we normally would call Y, but we've switched coordinate systems. So now we have to find the X component of this. And students get confused on this a lot, so let's do another example of how to do this. This is our new coordinate system. Let's draw the force right there in C. And now let's go through and finish this out. So let's extend those lines. And now let's draw that. Okay. So we've got the regular XY system that we always have, and then we have this new one. We've got our force here. Now we need to look at the angles. Notice this is 30 degrees right here. Okay. So if that is 30 degrees, find the matching angle on this diagram here. So it's 30 degrees between x and the horizontal line. That's this right here, right? So this is 30 degrees, this is 30 degrees, that's 30, and that's 30, right? So what we're looking for, we want the x and y components here for NC. So we're going to have that x component, that y component. Okay, so hopefully that helps you see how we get this one. So if that's the case, our NX component, that's opposite this 30 degrees, and it's going to the right. So we're going to have plus NC sine 30. Okay, and set that to 0. All right, so anytime you have a problem figuring out the angles, you can always try to draw this out. This is what I always do. It's what I used to do as a student, and I find it to be pretty easy. It's easy to see the components when you draw it out like that, rather than just kind of staring at it. So if you get stuck, try this out, see if it works for you. Now we've got the 3 unknowns in this one equation. We need more equations, obviously. Let's go to the y components. So for this one, we've got a y component right here for the 10-pound force. That is right there. That is going to be negative because it's down. So negative 10 sine 30. Now these two are just in the new x direction because they're parallel to this line. NC has a y component. We drew it right here. Right, so this one is going to be NC cosine 30. And it's positive because it's going upward. Set that equal to 0. And on this one, again, we're ignoring the gravity or the weight because we weren't told anything about mass. If you're not given the mass or it doesn't ask for you to find it, you can just leave that off of the free body diagram. Okay. Now this one, we only have one unknown, NC. We can go ahead and solve for NC here. We get 5.774 pounds. It's positive. That means we chose the right direction here. We still need one more equation because we still have 2 unknowns left. We have NA and then NB to solve for. So let's do a moment. You want to pick a point that has forces going through it. Makes it easier. I just went ahead and picked point C. And I'm going to say counterclockwise is positive. Okay. So now that we have that, let's find our moments. Alright, so first, let's see what we want to do. We need to find the moment due to NB. Alright, because this is a distance away. We've got this distance right here. That's the distance we need to travel. Now that's not given in this picture. Right? We have this angle, we have this 3, but we don't have this right here. But if you look, what that does give us, from what the problem has, is we can draw this triangle. This is 30 degrees, this is 3. We need to find this. Okay, so let's find x here. You can do that using the tangent, because we know tangent of 30 is opposite over, actually I drew this backwards, let's fix that. That ain't gonna work. There we go, that's right. Let's draw it that way. You guys were probably wondering what I was doing. Now we got this right triangle. This is 3 now, and this is 30. That's x. That makes more sense. Okay. Now that we have that, we can just do tangent. 30 is opposite over adjacent, so that's x over 3. So now you can solve that for x. We get 1.732 inches. So this is going to be the moment arm for NB. So we're going to have NB times 1.732. Is that going to be positive or negative? It's going to be positive, right? Because if we're here, think about this being able to freely rotate. If we push NB this way, this crowbar would want to go in a counterclockwise direction. So that's positive. Now let's go ahead and go to NA. So there's the force. We need the distance. This distance is given as 5 right here. All right, so here to here is given as 5. That's our moment arm. So we put 5 there. Now, is this one positive or negative? This one's going to be negative, right? Because if this was able to freely rotate and you just held this in place, this would go this way. Right, so that's negative. Now let's look at these two components for the 10-pound force. The 10 cosine 30 component, which is this x component. Let's do it first. We need the distance from here to here. This distance is 8. So basically we need 8 plus 5. That gives us 13. And that's going to be a counterclockwise moment, so it's positive. The y component, we got 10 sine 30. Now we want to bring it this way. That length, what do you think it should be? Hopefully you said 3, right? Because if you look in the picture, we've got this 3 here. That distance will be 3. Is that positive or negative? Should be negative. Because if you're doing this way, it's going to want to rotate clockwise. Now, is that all we got? Yep, that's all we need. Do we need to do anything with this? No, because it's going through point C already, so no moment is created. So set that equal to 0. Now we have 2 unknowns in this equation, 2 unknowns in this one. You're able to solve. Okay. So there you have it. And let's go ahead and simplify this one. Here you get 1.732 in B minus 5 in A. That's going to equal negative 97.583. So now you'll take this equation 1, this equation 2, and you'll solve those simultaneously. And then if you get that, you'll get that NA is 23.74 pounds, NB is 12.193 pounds. Okay. Those are both positive. That means we picked the right directions up here, right? Which we kind of already knew those were the right directions, but this confirmed it. All right, so this gives you your 3 normal forces that you have when you make contact with those blocks of wood. All right, guys, hopefully that one was useful to you. I'll see you in the next example.